This is Professor Rudy, and this video is about how to create user-defined functions in MATLAB that have multiple inputs, multiple outputs, or both. First, I'd like to start with the case of multiple inputs. So, to define a function, if you remember, we want to start a new file, and you start that with the word function. Then the first thing that you want to put here is what your output is going to be. For this case, I'm going to do the example of how to calculate the acceleration in the normal direction. So I'll call that a sub n. That's going to be my output. That's what I want to calculate. So I'm just calculating one thing in this function. And then that output equals, I need to give the function a name. So I'll call my function normal acceleration. And what I need to calculate the normal acceleration is the velocity and the radius of curvature. So if I put these in here, these are the inputs to my function. So if I can give this function the velocity and the radius of curvature, I can get a calculation of the normal acceleration. What comes after the function is comments. So in here, you can put name, date, whatever useful information about this file you want to include. It's always good to say what the function does. This function calculates the normal acceleration. Then it's a really good idea when you're defining your own functions to put a description of what the inputs and outputs are. So the inputs here are velocity, which is going to be given in some units. So if you know what units you're going to be working in here, it's great to include that here. So if we give velocities in meters per second and radius of curvature in meters, that will give me an output of a sub n, which is the normal acceleration, in meters per second squared. Then we want to include our calculation here, and whatever we put inside this function is what that's going to do when this function is called. So for this case, it's relatively simple. We have that the normal acceleration is the velocity squared divided by radius of curvature. And that's all we need. So this is similar to what we've talked about before on another video with y equals some function of x. You can have that be a function of as many things as you need for your calculation. So in this case, we have those two values. And when you go to save your function, you always want to save it with the same name here as you have here. That way, MATLAB will know where to find that function, so it can find this file to know how to run that code. So once we save that, then we have this function that we can call. We could call this from the command window, or we could call it from a script. So from the command window, we can say normal acceleration, and then if we had a velocity of 10 meters per second and a radius of curvature of 2 meters, we can run that, and then we'll get an answer. And that's telling us that we'll have a normal acceleration of 50 meters per second squared. I'd also like to point out that how we have these comments here in our function, you don't even need to have the function file open to see this information. What this is what the help command will do. If I call help of normal acceleration, what it's going to do is it's going to pull up those comments and display them on the command window. So even if I didn't have this function file open, I can still see that and get an idea of what this function is going to do and how to call it, what arguments it needs. So this is an example of using multiple inputs but a single output. So next, let's do a new example. And here, I'm going to talk about a case of multiple outputs. So you still define things in the same way. I do function. But because I want multiple outputs, instead of just having one variable here, I want to use a vector. And I'm going to place this vector in square brackets, and I'm going to define each of the outputs that I'm interested in. For this example, what I want to do is calculate some statistics for some given vector. So the ones that I'm interested in are the mean, median, max, and min, let's say. And these could be whatever values you're interested in. Now I have these as y underscore mean, median, max, min, because these names are functions. We don't want to use variables that overlap with function names. So I'm putting that in there, and I'm using y just because that's what I'm going to call my input. So I'll call this function calcstats, and my input there will be y. So y is some vector, and then I'm going to calculate some statistics for that vector. We can do comments to describe what's going on. So here, this function calculates statistics for a given vector. My inputs are just going to be y, which is some vector, and my outputs are, so that y mean is the mean of the input vector, y median is the median of the input vector, y max is the max of the input vector, y min is the min of the input vector. Okay, so remember, we put these comments in there. That's something we'll be able to see with the help command. So that's really useful information. And the more we put in there, the better. For more complicated functions, I would expect to see even more than this in there, telling us exactly what's going on with that function. But for here, this is probably good enough. Now, inside this function, we need to define each of those outputs. If you notice here, we're getting all these MATLAB warnings here. This is saying that function return value is not set. We have not defined y mean, or median, max, or min. And we also even have a warning here that's saying you're not using y. So if a function is not using an input, it shouldn't be there. And if an output is not defined, you're not going to get what you want. So we need to do that. So we can do this, and these are pretty simple. Y mean will be the mean of the input vector, and so on for median, max, and min. So if we do this, save our function, remember I want to keep that same name, so if I call my function calcstats, I need to save it as calcstats, or things will not work. So if I save that, now what I can do is I can calculate the statistics for some vector. Now, I don't need to define this vector with the variable y. Y is just what it's going to be called within the function. So I could even call some variable x, which is from 1 to 10. And then I can do calcstats of x. Now what happened here is when I called that and didn't define any of my outputs, it's just giving me one number. And we know we wanted multiple outputs. So what I need to do is actually explicitly spell these out of what I want each output variable to be. So here I'm using x's instead of y's because I'm talking about some variable x. And now we have, oh, and I have a typo. Alright, try that again. Okay, so we can see here then, we calculated the mean of 5.5, median was also 5.5, max was 10, min was 1. And you can do this for any input vector. You could create a, let's use a different variable now, let's say noise, and create some random noise. And let's do a million points. 10 to the 6 million points. So if we just look quickly at what this looks like, we've got this noisy signal here. So I want to know some statistics about this signal. So let's say noise mean, noise median, noise max, noise min is calcstats stats of noise. If I do that, I get my values here. So I had a mean value of this, median value here, and then my max and minimum values. And this is a way that you could use a function to get multiple pieces of information, even with only one input vector. So, for my third example, this will be multiple inputs and multiple outputs. So you can have both. And for this example, I'm going to use a dynamics problem, a simple dynamics kinematics problem. So here's the problem. We're throwing a ball from a tower that has some height h, and we're throwing it at some initial speed v0. And we want to calculate the speed when it hits the ground and how long it took to get there. So I'm going to solve this problem using a function. So I've already defined my equations using kinematics. So I started with this equation here, which relates the velocities and position through a constant acceleration. My change in position is just going to be equal to the height of the tower. My constant acceleration is equal to the acceleration due to gravity. And then if I solve this for velocity, I can get this relationship. So notice we have v as a function of initial velocity and height. And we also have this known constant g for acceleration due to gravity. Then to find the time, we can use this equation, which relates the velocities and the time through that constant acceleration, and we can solve this, where now we have time in terms of the velocity, which we've calculated, the initial velocity, and acceleration due to gravity. And I want to program these calculations into a function so I can solve them for different cases of height and initial speed. So, function, let's call the outputs here, we have the velocity v and the time t, and the name of this function, we want to have that somehow relate to what we're doing here. So maybe I'll call this baseball tower. That's probably not the best function name, but that's what I'm coming up with off the top of my head. And what we need as inputs then are the values defined as the given values in the problem. So we have an initial speed, v0, and then the height h. So notice, we define our outputs in a vector here. So these are the things we want to get, and here are the inputs. These are the things that we're going to give in the function. So I'll quickly put some comments in here. For the tower. Okay. You could also write stuff about your inputs and your outputs. I'm going to just cruise past that for the interest of time here. So then what we want to do inside this function is define the velocity. So v equals square root of v0 squared minus 2 times g times h. So v0 and h are given in the problem, but g is actually not. So we're going to need to define what that g value is. So we could put that here, and in this case, let's assume we're in feet per second squared. So because we have this g and we have this in specific units, it actually is going to be very important, so I will actually do it. Go up here and define our inputs and outputs. So the input v0 is initial velocity meters per second. H is tower height, and I'm already doing it. It has to be in feet per second and feet for these calculations to work out correctly. So then if I do that, I'll get outputs of the final velocity will also be in feet per second, and then the time of travel will be in seconds. So with these given values, as long as we have the right units, then we have this value of g, and we can program this in here. I actually realized there's a typo in here. Sorry about that. That should be a plus. So we calculate that velocity, and then we can also calculate the time. Once we have that velocity v, we can use that in our second calculation for time. So here, calculate the final velocity, and here calculate the time of travel. We save this. We want to save that as baseball tower. That's good. So then, just like with the others, we need to define this. So if we want to calculate the velocity and the time, we can call the baseball tower function and then give it arguments for v0 and h. So if we have an initial speed of 18 feet per second and a height of 50 feet, we can solve that, and then we'll get the values for velocity in feet per second and the time of travel in seconds. So that's some examples of defining user-defined functions for multiple inputs, multiple outputs, or both. Thank you.